right, let's begin. 5 o'clock. I'm super happy to be here to share this tool I developed to help us as developers using DQMH. The tool I developed is called Panther Sniffer for DQMH. It's a mobile app to sniff while are doing DQMH modules. My name is Enrique Noé Arias. Sorry. I want to talk about myself. I am a certified LabVIEW architect. I'm an electronics and telecommunications engineer. I have 2 master's degrees, one about electronics and computational systems, and another one about web and mobile devices development. I'm a LabVIEW teacher at the Universidad de La Salle Bajío in León, Guanajuato, Mexico. And I worked in an optics research center for about 13 years. At October of 2020, I started working as a software contractor at Delacor. Fabiola de la Cueva gave me this amazing opportunity. Thank you, Fab, for the mentoring, for the teachings, for the do's and don'ts. Thank you, Fab. And this year, I am starting Panther Lab, the first DQMH trusted advisor company in Mexico. These are the services I am providing. I am providing software consulting. I have experience in machine vision, DQMX, testing, etc. I am providing training about DQMH, LabVIEW, source code control, etc. So let's start with this hashtag or giants are female. I choose to talk about Angeles Elena Van Rysing. She's originally from Zacatecas, Mexico. She's one of the women responsible for the Kia Telluride, a truck sold in the United States. Her work consists in the easy driving and fuel efficiency of the truck. She's a mechanical engineer. She has this idea. Being a woman is not a limitation to do any work. So I think she represents our giants are female movement. Thank you for all the women in tech and science, and we are proud of her, of the women. Okay, I'm going to start with a little bit of background why I developed this tool. We as LabVIEW developers, we use LabVIEW to communicate with a lot of instruments, drivers, hardware per se. Sometimes we will test stations, test systems, and the hardware and the software are in different locations. So to watch the hardware and software interactions, we always need on the screen to watch it. Testing if the hardware works is an important and essential part of our development. So these hardware-software interactions make me think and make me remember this situation. Do you recognize this situation? A man or a person holding his laptop, doing the keyboard and the mouse with one hand. Sometimes we see people with the laptop on the knees, on dirty locations. The need of this situation is because we need to watch what is the hardware doing. We need to interact with hardware and software. That's why with this idea in my mind, I constantly think, what if I can, I just call LabVIEW with a mobile device, and ask LabVIEW, hey LabVIEW, what are you doing? And what if this situation can be solved maybe in a minor percentage with a mobile app? So I start the mission to build a mobile app. These are the three main objectives of my initial development. I want to build a mobile app to see in some way what is happening on the LabVIEW side. And the app should establish connection with LabVIEW in some way. The app must store the configurations as easy as is possible to make almost zero effort from the user. So I search for the connectivity options we have in our phones, on our smartphones. We have two, Bluetooth or Wi-Fi. To not talk about a lot of this, I choose Wi-Fi because with Wi-Fi you can achieve longer distances, faster speeds, and the most important why I choose Wi-Fi is because you can use a lot of standard protocols already including LabVIEW like TCP, etc. So the Wi-Fi has more pros than cons. The Bluetooth has the pairing, and for me it's like annoying. Sometimes my phone is connecting with a speaker and don't want that. So Wi-Fi is better for me, and I choose as a connectivity option for my development. And searching for the correct protocol, I often find this kind of image. This kind of image looks so familiar what I was trying to achieve. A laptop and a mobile device and some other things in the equation interacting all of them. So this image says something important, MQTT broker. So searching for the MQTT protocol, I found the MQTT is called Message Queue Telemetry Transport. It is a protocol very lightweight. It can work in a very limited resources devices, like a chip, like a bulb, like a switch, etc. MQTT started as a proprietary protocol in the oil and gas industry, and it was think to replace some SCADA elements. Today is an open source protocol. It's the leading protocol using the Internet of Things context. This protocol is a published subscribe protocol. So I'm gonna talk a little bit more about MQTT. MQTT, one important topic to understand about MQTT is that the couples the senders from the receivers. So in the MQTT context, the clients are the things. They are in like on a social network. So MQTT broker for me is like Facebook or Twitter, etc. The clients are the people publishing data. You have no, you don't have control who will view your posts. You don't know that. So everything is decoupled. So you can be publishing data and you can be subscribed to a specific data. So this is pretty much the main topic about MQTT. Everything was just a possible plan, but then Francois Normandy released the MQTT client and the MQTT broker for LabVIEW. Thank you so much, Francois, because I am using this library to build this project, Panther Sniffer for DQMH. Okay. I did a quick search and I found the library, the correct library in the mobile side. So I have the initial ingredients for building the Panther Sniffer for DQMH. In the PC or in the LabVIEW side, I have the LabVIEW, and I am a DQMH fan, so I am using DQMH. In the mobile side, I am using Flutter. Flutter is a framework. It's an awesome framework. And in the broker is LabVIEW again. So these are the ingredients. You can be talking between the mobile device and the laptop using this protocol. So I redefined the mission. I need to build a mobile app using Flutter to see in some way what is LabVIEW doing. And the app, it must establish connection with a DQMH module with the MQTT protocol. The app and LabVIEW act as MQTT clients. Sorry. So I'm going to talk a little bit about Flutter. Flutter, as I said before, is a framework, and the targets of this framework is build mobile apps, web apps, desktop, and even embedded apps. In the mobile apps, you can build for iOS and the Android side with pretty much outstanding performance and very nice looking. Flutter is one of the leaders of the framework, mobile framework usage. This graph represents the worldwide software developer working per hour per framework. So Flutter and React Native are the leading ones. And one thing to I didn't say framework. This framework Flutter is maintained by Google. React Native is maintained by Facebook. So this framework is 100% object-oriented programming. Includes a lot of classes. Some of these classes are called widgets. There is a widget catalog. What is a widget? A widget can be a button, a row, a column, an icon, an image, etc. So this framework has an enormous catalog of widgets, and you can install more as you need. In Flutter, as I said before, I searched for the MQTT library for the connection, and to achieve the third objective of almost zero effort by the user, I am using SCP Lite. SCP Lite is to store all the configurations for the user experience. So several of the GLA Summit talks today are about dependencies. So in Flutter it's very easy. You have a file where you place the name of the library and the version, and with the command you download all the packages, dependencies, libraries, etc. in the project. So the package and dependencies is per project. There are some rules in Flutter. A widget can contain another widget, and you will end having a widget tree. So why I'm talking about this is because I found similarities with the actor framework. So in actor framework, you have the root actor, the nested actors. In Flutter, you will have a widget tree. It's pretty much the same. In Flutter, you have two kinds of widgets, statelets and stateful. The statelets, there are widgets used to show something, ornamental stuff. and the stateful is widgets that can change the state, can do some computed with interaction with the users. In Flutter, all the widgets, as they are classes per se, they have properties and methods. So to show you how Flutter looks like, this is a text widget. The text per se is GLA Summit, and the property text align tells the widget how it will be aligned. And the style has a class as a wrapper for all the style properties. So it's pretty easy. You use semicolons to separate all the properties and methods of a widget. In Flutter, I must say there is another analogy with the actor framework. In Flutter, and in every Flutter project, you will have a main.dart file, and this main.dart has this run app. This run app is like the launch root actor method in actor framework. So I like when you are developing and you find similarities with your background knowledge, it's more easy to learn. So Flutter for me is pretty much like an actor framework, but for the mobile and web development. Okay. What about the DQMH on the LabVIEW side? Well, DQMH it's a very popular framework. Is developer friendly. This is one of the most important things. It enforces developer experience, and it has a vast and growing community. DQMH has a lot of scripting tools to help the developer to automate some repetitive tasks. And the last point is all the modules in Flutter. DQMH, you will develop modules. Each module comes with an API tester. This is important because with an API tester, you can develop and you can test your module as you are going. So each module, this is a DQMH anatomy. DQMH module is a library. It has a virtual folder called public API. The public API are the request events for the module, and each module comes with an API tester to exercise all the events in your module. Each module comes with broadcast. So, like I said, it's a developer-friendly, developer experience-friendly framework. So, this framework comes with a lot of broadcasts. These broadcasts are in private scope. It can be used only inside the module. These broadcasts are used to inform all the listeners in your application something happened, and to publish data. I'm going to talk a little bit more about it in the future. So this is pretty much an API tester. The API tester has these buttons to exercise the public API, and it has this status text to create like a log. What are doing, what the module are doing. So this event, broadcast event, status updated, acts like a debugging tool. So you can use status updated to inform the module is doing this, has doing this, has doing that, etc. This is important because I am using this status updated, so debugging tool, to create this application. I'm gonna talk a little more. So what is Panther Sniffer for DQMH? It's a mobile app. It can run on Android devices by now. It is a simplified API tester in your phone. So if you are familiar with DQMH, you will have an API tester in the palm of your hand. You can watch the status updated broadcast event as it is triggered by your module. Also, you can trigger some predefined requests. They show from panel, show block diagram, stop module. The app allows you to communicate to a specific instance because you will have a DQMH clonable model. I'm going to talk in the future slides. So in the LabVIEW side, Panther Sniffer is coupled with a new DQMH module template with an MQTT client inside. Both the app and the VI, the package are free and available in the VIPM and in the Google Play Store. This is the first video to show you how the Panther Sniffer for DQMH works. Okay. After you install the package, you can add a new module to your project, and this module, this package will add a new module template, the MQTT client. This MQTT client is pretty much complete to connect with the app. Each module comes with a simple MQTT broker to allow to create your first MQTT network. When you run the broker, you have the information and you can connect this new module to your broker. In the app, you can add brokers and modules with the plus button. First, you have to add a broker, just capturing the information that is shown by your broker. This is the IP address, the broker port. You click Save. Then you add a module, and the module has to, the name, it must be the same as your module. So in this case, the module is called Panther, and you select which broker to use. So you use tab, and there you go. You have the app and the module connected. You can trigger some predefined events in your phone, and there you are showing the panel, and you also you are seeing the status updated string. Right now, I am running more instances of the same module and connected to the broker to watch the status of string updated in the app. You can select which clone to communicate. In this case, I'm communicating with the two. This is pretty much easy. Okay. So what is happening here? You have the app, and you have the module, and you have the broker. The broker can be running on the same developing machine, but you can run the broker in your local network. Even you can have a broker in the cloud. But as I said, the purpose of this tool is to debug the hardware-software interactions, and you need to be near to the hardware to test it. So what is happening here in MQTT, you need topics to publish and subscribe. As I said before, MQTT is a publish-subscribe protocol. So the app is publishing this topic, module name, module ID, DQMH, MQTT, and this topic is the same. The module is subscribed. In the other sense, the module is publishing on the module name, module ID, status updated, and the app is subscribed to that topic. This is the core of the Panther Sniffer for DQMH. The name, each DQMH module comes with a constant BI called module name. So you don't have to worry about it. When you create a new DQMH module, the name, these topics will be formed automatically for you. So this is the setup. You have the client and the broker and another client. The status screen in the module is now in the palm of your hand. So if you don't have access to the API tester, but the module is running and the module is doing stuff, and you want the API tester be shown, but you cannot watch because it's far away from the hardware, maybe Panther Sniffer could be a possible tool to help you. So in LabVIEW development, when you install the MQTT client, there are examples that Francois Normandin provide. So this is a client he provides. It's pretty much an event handling loop. So it makes sense when you are in DQMH to embed this MQTT client in the event handling loop. The first approach was to add it to the DQMH module as a helper loop, but then I realized I needed it made more sense for me to add the client in the event handling loop. In more detail, there is a request already created in this new DQMH template, module template. This connect client creates a new MQTT client and allows the DQMH module to be subscribed to the new MQTT client events. So this is the create client. Inside the create client, this is what is happening. I am choosing to use TCP IP. You need the IP address, remote port. We are creating the client, and I am using JSON serializer because in the app I am using JSON also. Here at the bottom, I am creating these topics dynamically with the module name, module ID, etc. And this is a constant BI with the final part of the topic to allow this module to be subscribed to the app's publication. So when you create the client, and if everything is a success, the same client will be subscribed to to some specific topics. This is the constant BI I was talking about. This is a string, DQMH MQTT. It's like a password. Then I am forming these topics. Demo is the module name, /1 / DQMH MQTT. /1 is the module ID instance. So I am creating also demo /alt / DQMH MQTT, because as this is a DQMH module, clonable module, with the app, I can talk with all of the modules or to a specific instance. So after the client creation, The next step the module does is to subscribe to these topics. This is where the event is triggered, and this is the user event the DQMH module has to be subscribed to these topics. So this subscription is to allow the app to communicate, to establish communication with the module per se. The disconnection of the client is pretty much straightforward. You just stop the client and release all the resources and inform the message handler the status of the connection. So how the app communicate with the module. Right now, I just tell you how the app subscribe to the app publications, but how the module publish data. The first change is to allow the module itself to be subscribed to its own broadcast. Each DQMH module comes with two functional global variables, one for the broadcast events and one for the request events. So by default, each module it's only listening the request events. So I modify a little bit the template to subscribe to the broadcast. Then, if I allow the module to be subscribed to the broadcast, I can subscribe to the status updated. This status updated is a broadcast by default in every DQMH module. And it is like a debugging tool for me, like a console.log, console.write, etc. printf. In another programming languages, in DQMH is the status updated. It's like a generic debugging tool. So if the module is subscribed to its own broadcast, then each status updated of the module itself will be published to the MQTT network that you create. This is pretty much the same. I have a constant BI with like a password to the status updated topic, and I am recycling the same BI to format to this module. This is the status updated string and format to this module, and this will create the module ID, the module name / module ID / status updated. This topic is the one that the module uses to announce something happened, and the app is subscribed to this topic. This is the way the app can be listening what you are doing in your module, what the module is doing. So as you can imagine, the app has these two passwords, DQMH, MQTT, and status updated strings as constants to create the topics. Each module in the app, in the SCP Lite database, is a class. It has an ID, a name, and a broker ID. I have another table for the brokers. So the modules and the brokers are two relational databases, data tables. So when the user clicks on a module in the app, these elements, this is the first that happens. You create the topic specific and the topic all. This is my naming. So module name / ID to string / message topic. This message topic is this. Topics all is module name / all message topic. So I am creating the topics to allow to communicate the app to the module. So after that, I initialize the MQTT client in the app, And this is pretty much straightforward what the AP of the MQTT client says. I am setting the port, the protocol version, and etc. etc. Then what happens next is to subscribe to some topics. This is the subscribe to, and this is the method to publish data. So it looks like a little bit complicated, but they are not as complicated as it seems. So I think this is demo time. Let me see if I have. Okay. Please, if you have questions, place it on the chat. I have some polls, two questions. If you are interested on this app on iOS devices, and what kind of smartphone do you use? Okay, this is the demo time. This is a module. It is a project with a module. I have this demo. Demo is the DQMH module, and this is the MQTT local broker. So I can run the broker. This is the broker info, and here I have the app. Okay. This is my phone, and I am using like a remote desktop for phones. So let's give you a little bit a tour in the app. When you open the app, you have brokers or modules in the bottom. You can select what do you want to see. To add, for instance, a broker, I can add it as you just place a name, like the name of your machine, or etc. Demo. You can place IP address. And a port. You can also use URL, because you can use free MQTT brokers already available. So this demo, if I click and hold the demo, I can see the information. And if I don't want this element, I can erase the module, the broker, just dragging to the side. I have another brokers, but if I want to delete some brokers, I cannot do that if they have DQMH modules attached. So I have this lab, is the same information I have in this broker, and I can add a module. Let's erase. I'm gonna add this demo. As I said before, I can add the name. I must add the same name, demo, and I have to select which broker I'm going to use. So I'm choosing lab, and I click save. So if I click demo, I just have one client connected, and I can open now the API tester. And I can, as I am running the module in the same computer, I can connect immediately to the local host. Now I have 6 clients, and I can see the status updated after the clients are connected. So in the app, I can just click the open module, open front panel, and I have now all the front panels open. Then I can use the hide mode panel, and I trigger this predefined event using the app. And what if I want to see the module ID one, the block diagram, so I can call this predefined event. Okay. What if I want to kill the number number two? So I can select the two and then click the stop module instance. And now there you go. I don't have the instance number two. So how do we use this? I can stop. If I just create a new event for this module, like two numbers. So if I want the module add two numbers, but and I want to be a request and wait for reply. I want an answer. Okay. So how this is related to Panther Sniffer for DQMH? When you are developing DQMH modules, you can add a request and do coding. Okay. I'm gonna place here B and A. Okay. This is the DQMH module, and I can now add the elements and have an answer. So what if I want to use Panther Sniffer? I just place the status updated here, and I'm going to use this. Well, Fab says I should use this. Okay, and I have to write an string like a debug string. So I'm going to use the formatting string. So I'm going to use the A and the B and the output. Sorry, I can see very clear. Yeah. I'm gonna edit. So I have A. I'm gonna place 1 decimal point. B. decimal point equals e, I'm going to put 1 decimal point. Okay. So I have a function. I think I didn't connect to the status updated. Okay. Status updated string. Yeah, there you go. So I run this BI, this module, I run an instance. I have to be connected to the broker. So I'm going to connect the app. I'm connected. I'm going to connect the module. I have this. So if I want to use the API tester, I'm going to place 3, 4, add 2 numbers. So now I have in the app the status updated string, demo 1, A4, 4, B3 equals 7. So this is pretty much how to use the app. This is the first example. You have okay, Luis is asking if the app has a memory restrictions. No, there are no restrictions. You can run the app for hours. I must say there is no problem to let the app open. I don't know if you mean restrictions about how many elements can you add as a context, but there are no limits as your phone allows it. Yeah, there are plans to Matthias. Says if there are plans to allow the app draws a more complete API tester if the module can provide all the information to draw a more complete app. Yeah, there are plans to build a mobile app more complete. This is the version 1. So I'm going to pass to the second example. What if you have already an app, a program in LabVIEW, and you want to use Panther Sniffer? So this is a CML project that comes with DQMH. You can run the CML main. Okay, this is the CML main. So I created, I added a module called CML in this project. This CML, what it's doing? This CML, is listening to the broadcast of the UI module that these examples has as a file. So when the application, the existing application has a status updated broadcast, what I am doing is using the status updated that the module uses. So the app doesn't know anything about my module. This module is just to sniff what is happening on the existing application. So I'm going to run this module. to sniff what is CML doing. Start, connect client, and connected. So in the app, I open the CML. Now I can use the CML as the default. When I click calibrate, the existing application is broadcasting the status updated. It is broadcasting the device is successfully calibrated. If I click start, I am seeing the information in the app. If I click the stop, we are seeing the information in the app. So this module can be used as a sniff of your existing applications. So you only have to subscribe to the broadcast in your app, or you even can create a new request for this new DQMH module to publish data to the app. So this is the second example. Thank you, Matthias. Please, if you have questions. I have this third example. This example is on a real-time target. It's on my Rio. I have my Rio connected in my desk. This is a module inside my Rio. What is the module doing? The module is pretty much a singleton module. What it's doing is it has a helper loop, and it is pulling the status of the buttons and pulling the status of the accelerometer. And I already with an application. This is the application. What I did here is to embed the broker and the module. I'm not super expert in real time, but these two loops are running now in the my Rio. So I have this my Rio example. If I click the my Rio, the my Rio has another IP address. This is the IP address of my Rio. So I'm going to connect to the my Rio. And now I can watch what is the Rio doing. In my Rio, I don't have a screen. So this application is just to see the hardware interactions. I'm going to push the button. Oh, yeah, there you go. If I click true, false, and I can see the accelerometer changing as I am moving my Rio with my hand. The my Rio is running this application I show you. Yes. Another thing. Because I can use the show from panel and show block diagram, what I did is to pull this message, and I can be changing the LED status with this request, just to show you I am interacting with my Rio. This is pretty much my presentation. Do you have another questions? Thank you, Eli. Thank you, Matías. Thank you. César. Muchos amigos. A lot of friends. Thank you. Did you answer the polls? Show results. Yeah. A few votes. Thank you. Well, 100 wins. Yeah. Okay. So, thank you. Thank you so much for watching my presentation. And if you have questions, you can reach out to me. Send me an email, or you have my business address, etc. Thank you.